My dear students, this is Aminur Rahman, Assistant Professor of Mathematics, Dhaka College, Dhaka. I welcome you to the online class conducted by the authority of Dhaka College. My dear students, earlier in offline classes in the college, we have discussed regarding groups. In succession of those classes, I'm now going to discuss an important problem. So let's go to the whiteboard and write the problem. Dear students, we know for a group, four conditions are very necessary. So please write on the problem. Show that G A and A, where A stands for a real number, form a group under the operation multiplication where E is the identity element, to be determined and each element has inverse. With respect to E. My dear students, you have already seen the statement of the problem. The problem says show that G is a set of two matrices. So this set will form a group under the operation multiplication, where E is the identity element. Here stated that E is the identity element, but we have to determine that identity element, and every element in Z there will exist inverse with respect to E. So dear students, we gradually prove the four conditions to be a group. We know that a set needs four conditions to be a group. First condition is closure property, second condition is associative law, and third condition is existence of identity, and fourth condition is existence of inverse of each element. These four conditions we need to prove a set to be a group. So dear students, first we start for closure law, and to prove closure law we need at least two elements, and we'll consider two elements, and we'll see that the G follow the closure law. So dear students, we start the proof. Let A and B be two elements of G. Let A and B be two elements of G, where if A and B are two elements of G, so A and B will be the form of this type of 2 by 2 matrices. So dear students, we are giving explanation of A and B, where A equal A and A, and B equals B and B. A and B stands for real numbers. Okay, dear students, we consider two elements, and now we will show that G hold closure property. So, and the operation is multiplication. So we multiply A and B. A and B, this equals, we know what's closure property is. Closure property is multiplication of two distinct elements will be again the element of that set. So we multiply the two elements of group G. So complete the multiplication of the two 2 by 2 matrices, and we have AB plus AB, AB plus AB, and AB plus AB, and AB plus AB. So 2AB or 2AB, 2AB and 2AB. Okay, dear students, just observe the fact, whatever will be the element of G will be this type of big, and all elements will be same. All elements will be same. Here the element is A and A. Four components of the element are A and A. That means all the components of the element will be same. And here we observe all the components of the all the entries of the matrix are same. So this will be the element of G again. So this belongs to G. Okay, this belongs to G because the elements are of the type of this element, is of the type of this element. That's why we can say so G holds the closure property. Dear students, so closure property we show just closure property. Here you can write closure properties. Closure property hold, and gradually we will prove that the set holds existence of identity, existence of inverse and associative law. Then next we are going to prove associative law, but here see multiplication is again the elements of G. So dear students, now we are going through the associative law. Associative law. You can show associative law, but associative law is very easier. That's why we consider three elements A, B and C, where A is of the type A, B is of the type B, and B. That means all the entries will be same, dear students. C, and C. All the entries are same. So here in A, all entries are A. Here all entries are B. All entries are C. So dear students, in intermediate level we have proved this type of problems. A into BC, this equals AB into C. I mean matrix hold associative law in general. So it is not necessary to prove. It will just consume our time enough. So in what we can say that associative law hold. We know matrix multiplication, we know matrix multiplication is associative, so easily we get, easily we can prove A into BC, B is equals A of B into C. Okay, dear students, you can directly prove this, or you can say this. Thus we mean the group G holds associative law. So, or thus G holds associative law. Okay, dear students, now we have two properties to prove, and that properties are existence of identity and existence of inverse. Here just observe in the problem, identity element exists, but you have to determine that element. Okay, identity element exists, but you have to determine that element. Here to be determined, that means you have to determine that element particularly. Also here say identity element of course exists, but you have to determine what it is. Okay, so we are going there. Let's write existence of identity, existence of identity. Okay, dear students, so let's propose an identity element E. Let E is the identity element of G, where E equal E, and E. We know whatever will be the element of G will be this type of, all the entries of the element will be same. That's why as we propose, E is the identity element of the set. So this should be this type of, I mean all the entries will be same. All the entries will be same. That's why all entries has become E, E and E. Okay, dear students. Now for any element A we get. Now for A and A belongs to Z, we get A equal EA equal A. Okay. Because we identity element exists and we proposed E is the identity element, so this is the property of identity elements. Identity elements is that element which actually has no influence if it is attributed to any element. I mean, if you attribute this, if you operate this element with another element, it will create no change. It will create no change. That's why we multiply E with A and E with A, and once again A come back. So E has no influence, we mean, dear students. So and here it is said you are to be determined. Identity element to be determined. So we are now going to determine that identity element. Okay, dear students. So from here we are taking a part only. A and A. E and E. A and A. Okay, dear students, we just put up the values of the elements, and we are coming here. We need a space. So erasing this portion, dear students, complete the multiplication, please. From here we come here, just complete the multiplication procedure. AE plus AE, A plus A, A plus A, and A plus A. This equals A and A. So twice A and twice A and twice A, this equals A and A. So from the property of matrix equivalent matrix, from the property of equivalence matrix, we get, here students, we get twice A, this equals A, twice A, this equals A, and from here E equal 1 by 2. Okay. So dear students, in the problem it is said you are to determine the identity element. Is the identity element? Of course identity exists, but you are to determine that elements what it is. So E equal half and half, and this is the identity element of the group G. So equally, thus the identity element exists. Thus the identity element exists in G. and E equal identity element E. E exists in G and E equals half, half, half and half. Okay, dear students. So among the 4 properties, we have already proved 3 properties. Thus, one condition is remaining to be a group for the set G, and we are going there, and that is existence of inverse of each element. Existence of inverse of each element, and here it is said each element has inverse with respect to E. That means inverse exists, but we have to prove with respect to E, and E has already been determined by us. So dear students, existence of inverse of each element. Okay. Let B equal B, B and B, B is the inverse of the element A equal A and A and A. All the entries will be same with respect to E. Okay. আমরা এটা ধরে নিলাম ডিয়ার স্টুডেন্টস। সো এখন আমরা আইডেন্টিটি এলিমেন্ট so we will now determine the identity element, inverse element of A. So please apply the condition of inverse element, and we get AB is equals E. Dear students, AB means A and A. B means B and B and B, and E you have already determined half and half. Okay, dear student, now complete the multiplication on left side. So AB plus AB, AB plus AB, and AB plus AB, AB plus AB. This equals half and half. Okay. Next, we need more spaces. Dear students, come here. 2AB, 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 2AB. This equals half and half. So now using property of equivalent matrix, we get 2AB. This equals half. Therefore, P equal 1 by 4A. Okay. Dear students, we get 1 by 4A. So inverse of A is we already consider B is the inverse of A. So now the inverse element becomes here. Thus, the inverse element B becomes B equals, instead of B just replace 1 by 4a, 1 by 4a, 1 by 4a, 1 by 4a and 1 by 4a. Okay, all the entries are same, so it's once again belongs to Z, dear students, once again belongs to Z. So we can say existence here, here A was arbitrary, so whatever A is, there will exist, whatever A is, there will exist inverse element of each element. So we can say so inverse of each element exist in G. That is G hold inverse property, dear students. J holds inverse property. So gradually we have already proved the 4 conditions for the set G to be a group. So we can now declare that Z is a group. So just conclude the problem. Since G holds the set G, since the set G holds all the properties of a group, so G is a group. Hence complete. Hence complete, dear students. Very easy proof, and if you try your best within a short time, you will be able to prove this type of problems. And according to this procedure, we can prove set of integers form a group. Set of integers this and these sets form a group under multiplication. Set of real numbers except the element 0 form group under multiplication. So following this process, we can prove these sets as group. So dear students, just carry on your studies because exam is very ahead to you, and be careful regarding Omicron virus. So no more today. Try your best to remain safe. Allah Hafiz.